Okay, today's lesson is lesson number 96. We're going to be talking about finding the distance between 2 points. Okay, so yesterday we kind of talked about this as well, but we focused mostly on how to do this geometrically, so using a graph and talking about the length of the segment. But today we're going to build on this and use the distance formula. Okay, this is useful because sometimes the points aren't exact, right, and it might be difficult to count, or maybe they're really far apart, so it might be difficult to count that way. So that's why the distance formula is useful to us. Okay, so let's look at what we did yesterday. Okay, so we were given some 2 points and we wanted to know the length of the segment between them. So we created this right triangle. We looked for A and B, and then we were able to find C using the Pythagorean Theorem. Okay? So now let's look if we just have generic points. So we call them x1, y1, x2, y2. Let's see, could we find the distance between them? Okay, so this distance here, if the y-coordinate down here is y1, I find this distance just by subtracting. Okay, so if the y-coordinate here was, say this point was like, I don't know, 10, 15. Okay, and I wanted to know what's the distance between that point and, say, the point 5, 10. Okay, so if the y-coordinate down here is 10 and the y-coordinate up here is 15, doesn't it make sense that this distance would just be 5? Right? So you're just subtracting. When you're finding the distance vertically or horizontally, we said you can just count, but really you can just subtract as well. Okay, so let me kind of get rid of this stuff, and then let's look at the horizontal distance here. Okay, so over here the x-coordinate would be x2, so that would be 10. So I'm thinking, okay, what's the distance between 5 and 10 for the x's? Well, again, I just subtract, right? And I would get 5. So I can think of this distance as x2 minus x1. Okay, so if I plug these into my Pythagorean theorem over here, I get x2 minus x1 squared plus y2 minus y1 squared. Okay, and then instead of using c, since we're talking about distance, I'm going to call this side d. Okay, so then I plug this in for c here, and so I get d squared. Okay, so I get x2 minus x1 squared plus y2 minus y1 squared equals d squared. And then solving for d, I would just take the square root of both sides. So I get d equals the square root of all of that. Okay, so the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, and again, this is just like the Pythagorean theorem. Okay, I'm talking about the sum of the squares of the legs. Okay, this is the horizontal leg. This is the vertical leg. And that equals the square of the hypotenuse. Okay, but it's not squared anymore because instead we're just taking the square root of everything. Okay, so that is what we call the distance formula. We're able to use this now to solve for the distance between any 2 points. All we have to do is plug them in, and we don't need to make the whole drawing now like we did yesterday. It's nice to know, though, that this is where it comes from. Okay, so this formula doesn't just appear out of nowhere. It comes from this idea that between any 2 points, we can create a right triangle and solve for the distance using the Pythagorean theorem. So since we can do that, we can rewrite it with generic ordered pairs and solve for the distance that way. Alright, so here's our steps for today. Pretty short. You're just going to label the points. You plug them in to the distance formula, and then solve for d. Okay, so basically you just solve this part, and you get your answer. Alright, so moving on to some examples here. Example 1, I'm going to start by labeling my points. That's how I'm always going to start these. Even now, through college and everything, I still would label my points like this, okay? It's just silly not to take the extra, 2 seconds to label it to make sure that you do it correctly, okay? So I labeled the points. I rewrote the formula so I know what to plug my values in. So that I know what to plug the values into. So now I'm just plugging in x2, I get -2. x1 is -8. That's squared. y2 is 4. And then I have minus, and y1 is 0. Squared. Okay, -2 minus 8 is really just like -2 plus 8. Okay, the minus and negative here becomes positive. So that gives me 6 squared plus 4 squared. 6 squared is 36. 4 squared is 16. And when I add those, I get 52. Okay, the square root of 52, I can simplify. That's just 4 times 13. Four is a perfect square, so I can rewrite it as 2 squared times 13, and the 2 comes out, so it's just 2 rad 13 for my final answer. Okay, again on number 2, I start by labeling the points and writing the distance formula. When I plug in the values, let's go here. Okay, when I plug in the values for x2, I have -6 minus -1 for x1. -6 minus a -1 is just -6 plus 1. So that gives me -5 squared plus -10 squared under the square root. When I square a negative, I get a positive, right? Because a negative times a negative equals a positive. So this is just the square root of 25 plus 100, which is the square root of 125. I know that I can simplify this because 25 is a factor of 125. And it's a perfect square, so I rewrite this as 25 times 5 under the square root, and that's just 5 squared times 5. So this 5 comes out, and I get 5 rad 5 as my final answer. Okay, moving on to our next examples. Just continuing in the same way, okay? I label the points. I rewrite the distance formula. And, Okay, rewrite the distance formula, and I plug in these numbers. Okay, so x2 is 8, x1 is 0. y2 is -8, y1 is -4. Make sure that you are subtracting the numbers. Okay, so when I subtract 8 minus 0, I get 8. -8 minus a -4 turns this into -8 plus 4. Which is -4, so that's squared. That gives me square root of 64 plus 16. When I add, I get 80, and simplifying this square root, the biggest perfect square in 80 is 16. It's 16 times 5, and 16 I can rewrite as 4 squared. The 4 comes out, and I have 4 rad 5 as my final answer. Okay, for this one you might be tempted to say it's square root of 80 is 4 times 20, so that 4 is 2 squared and it comes out as a 2, so that's 2 rad 20. So some people had this as their final answer, and that's close, but the 20 can be simplified more, right? I can rewrite that as 4 times 5, and 4 is just 2 squared, so another 2 would come out, and I would end up with 4 rad 5. So the same answer, but kind of a longer way of getting there when you don't realize the biggest perfect square. Okay. Moving on to number 4, again, more of the same. This is x1, y1, x2, y2. The distance formula. Again, this is super important to label and to write the formula. I know it seems repetitive, but this almost guarantees that you're going to get the problem correct, right? It's just plugging it in at this point, You don't want to lose points because you just switched a negative to a positive or something. And having it written down right above will help you to plug in the numbers correctly. Okay, so plugging these in, x2 is negative 1, x1 is negative 3, y2 is negative 8, and y1 is negative 5. So lots of negatives going on. Negative 1 minus negative 3 is like negative 1 plus 3. Negative 8 minus negative 5 would just be negative 8 plus 5. Okay, negative 1 plus 3 is 2. Negative 8 plus 5 is negative 3. 2 squared is 4. Negative 3 squared is 9. Adding those, I get 13, and that can't be simplified any farther, so that's my final answer. Okay, and if you want some more extra practice and want to be able to check your answers, go ahead and work on these two examples as well. Very similar to the rest that we've been doing. Here is the work and the correct answers for these. Okay, so number 5, again, labeling and then writing the equation are always the first two things that I have. And then plugging in the values. This one I ended up with negative 2 plus 4 and then negative 1 minus 5. The plus is because it was negative 2 minus a negative 4. So I did skip a little step in there. Okay, 2 squared is 4, negative 6 squared is 36, so I ended up with square root of 40, which simplifies to 2 rad 10. And then over here at number 6, this was actually a perfect square, so you get 10 as the final answer. Alright, and that's it for today's lesson, so please work on these problems, and I will see you guys tomorrow. Thanks.